Cloud for AI 1. Introduction and Recap 1. Can explain AWS services like EC2 Lambda S3 API Gateway VPC RDS. EC2, Elastic Compute Cloud, a web service that provides resizable compute capacity in the cloud. It allows you to run virtual servers instances to host applications, databases, or other workloads. You have full control over the OS and configuration. Lambda, a serverless compute service that lets you run code without provisioning or managing servers. You pay only for the compute time you consume. It is event-driven, meaning it runs your code in response to events, e.g., an upload to S3, an HTTP request via API gateway. S3, Simple Storage Service, an object storage service that offers industry-leading scalability, data availability, security, and performance. It stores data as objects within buckets. It is commonly used for backups, static website hosting, and data lakes. API Gateway, a fully managed service that makes it easy for developers to create, publish, maintain, monitor, and secure APIs at any scale. It acts as a front door for applications to access data, business logic, or functionality from your backend services, like Lambda or EC2. VPC, Virtual Private Cloud, lets you provision a logically isolate section of the AWS cloud where you can launch AWS resources in a virtual network that you define. You have complete control over your virtual networking environment, including selection of your own IP address range, creation of subnets, and configuration of route tables and network gateways. RDS, Relational Database Service, a managed service that makes it easy to set up, operate, and scale a relational database in the cloud. It allows you to create instances of databases like MySQL, PostgreSQL, MariaDB, Oracle, and SQL Server, handling tasks like backups, patching, and scaling automatically too. Can apply knowledge from these AWS services to conceive a possible solution for a ML pipeline. Example scenario. Image Classification Pipeline 1. Ingestion S3. User uploads an image to an S3 bucket, e.g., Input Images bucket. 2. Trigger Lambda. The upload event triggers a Lambda function 3. Preprocessing Lambda. This Lambda function preprocesses the image, resizing, normalizing, and perhaps stores the metadata in RDS4. Inference EC2 or SageMaker. The Lambda function invokes an endpoint hosted on EC2 or SageMaker, where the ML model is running 1. To perform the classification 5. Result storage, S3 RDS. The prediction result is stored back in a different S3 bucket or updated in the RDS database 6. Access, API Gateway. A front-end application requests the results via an API gateway, which triggers a Lambda to fetch the data from RDS S3 and return it to the user 3. Can define cloud computing. Cloud computing is the on-demand delivery of IT resources, such as computing power, storage, and databases, over the internet with pay-as-you-go pricing. Instead of buying, owning, and maintaining physical data centers and servers, you access technology services on an as-needed basis from a cloud provider like AWS4. Can describe the different cloud service models. IaaS, Infrastructure as a Service, provides the basic building blocks for Cloud IT. It provides access to networking features, computers, virtualer on dedicated hardware, and data storage space. Example, AWS EC2. PaaS, Platform as a Service, removes the need for organizations to manage the underlying infrastructure, usually hardware and operating systems, and allows you to focus on the deployment and management of your applications. Example, AWS Elastic Beanstalk. SaaS, Software as a Service, provides a completed product that is run and managed by the service provider. In most cases, people referring to software as a service are referring to end-user applications. Example, Gmail, Salesforce 5. Can describe the difference between vertical and horizontal scaling. Vertical scaling, scaling up-down, increasing or decreasing the power of an individual resource, e.g., adding more RAM or CPU to existing EC2 instance. Pros, simple to implement initially. Cons, has a hard limit machine capacity, often requires downtime for upgrades. Horizontal scaling, scaling out in, adding or removing the number of resources, e.g., adding more EC2 instances to a fleet to handle increased traffic. Pros: theoretically infinite scale, better fault tolerance if one goes down, others take over. Cons: application must be designed to be distributed stateless. 2. 6. Can explain the concept of S3 buckets, lambdas, and API gateways and implement. Concept: S3 bucket, a container for objects, files. Lambda, a function consisting of code that executes in response to events. API gateway, an HTTP endpoint that clients call to interact with your backend. Implementation flow, serverless API. 1. Create an S3 bucket. Go to S3 console, create bucket, name it 2. Create a Lambda function. Go to Lambda console, create function, author from scratch, choose runtime, e.g., Python, write code 3. Set up API gateway. Go to API gateway console, create API REST or HTTP. Create a resource and method, e.g., GET, integrate it with the Lambda function you created. 4. Deploy. Deploy the API to a stage, e.g., dev. Now, hitting the API endpoint triggers the Lambda, which purely runs logic or interacts with S3. 7. Can be critical of AWS cloud and describe disadvantages. Cost management. It is very easy to spin up resources and forget about them, leading to unexpected bill shock. Complex pricing models can be hard to forecast. Vendor lock-in. Using proprietary services, like DynamoDB or specific AWS ML tools, can make it difficult to migrate to another cloud provider on-premise later. Security complexity. While AWS is secure, the shared responsibility model means the user is responsible for correct configuration. Misconfigured S3 buckets or security groups are common sources of data breaches. Learning curve. AWS has over 200 services, making it overwhelming for beginners to know which tool is right for the job. Latency. For some ultra-low latency applications running on public cloud infrastructure, which might be physically distant, can be slower than on-premise solutions, though edge locations help mitigate this. 2. SageMaker 1. Can describe the different steps in the ML pipeline. 1. Define business problem. Understand what you are trying to solve and the value it brings. 2. Problem framing. Translate the business problem into a machine learning problem, e.g., classification versus regression. 3. Data collection. Gather raw data from various sources, databases, S3 API. 4. Data preparation, ETL. Clean, transform, and explore the data. This includes handling missing values, outliers, and visualization. 5. Feature engineering. Select and transform variables to improve model performance, e.g., one-hot encoding, scaling. 6. Model training. Train different algorithms on the training dataset. 7. Model evaluation. Test the model on unseen data using metrics, accuracy, F1 score, RMSE. 8. Model deployment. Make the model available for use, e.g., as an AP endpoint. 9. Monitoring. Continuously track model performance and data drift in production. 2. Can describe the different steps in ETL and its different levels of implementation. Steps. Extract. Reading data from various sources, databases, files, APIs. Transform. Converting data into a suitable format structure. This includes filtering, sorting, aggregating, joining data, cleaning, removing nulls, and data type conversion. Load. Writing the transformed data into a destination target, data warehouse, data lake, or database for analysis. Levels of implementation. Batch processing. Processing a large volume of data all at once at scheduled intervals, e.g., nightly. Stream processing. Processing data in real time as it arrives, e.g., Kinesis or Kafka. On demand, triggered events, e.g., Lambda functions. 3. Can create a notebook in Amazon SageMaker AI. 1. Go to the Amazon SageMaker console. 2. In the left navigation pane under Notebook, choose Notebook Instances. 3. Click Create Notebook Instance. 4. Enter a notebook instance name. 5. Choose an instance type, e.g., MLT2 medium for low cost. 6. Under IAM role, create a new role or select an existing one that has permissions to access S37. Click Create Notebook Instance. Use OpenJupyter or OpenJupyter Lab once status is in service. 4. 4. Can implement the different steps of the ML pipeline in a notebook. In a Jupyter notebook, you typically ingest, import pandas as pd df equals, explore df head, df describe, matplotlib pyplot for graphs, preprocess df filna, sklern preprocessing for scaling. Train, use SageMaker estimators or built-in algorithms like XGBoost. Python import SageMaker from SageMaker. XGBoost, estimator import XGBoost estimator equals XGBoost. Role equals role, instance count equals 1. Estimator, fit inputs equals train input asterisk deploy, Python predictor equals estimator. Deploy initial instance count equals 1, instance type equals ML, M4, XLarge 5. Can describe different ETL solutions. AWS Glue, a fully managed serverless ETL service that makes it easy to categorize, clean, enrich, and move data. It has a data catalog to store metadata. Amazon EMR, Elastic MapReduce, a managed cluster platform that simplifies running big data frameworks, such as Apache Hadoop and Apache Spark, to process vast amounts of data. AWS Lambda can be used for lightweight, event-driven ETL tasks, e.g. formatting a file as soon as it lands in S3. SageMaker Data Wrangler, a GUI-based tool within SageMaker Studio, specifically designed to simplify data preparation and feature engineering for ML6. Can deploy an ML model in Amazon SageMaker. AI deployment in SageMaker typically means creating an endpoint that can serve real-time predictions. Using the SDK. After training an estimator, you call the deploy method, Python predictor equals estimator. Deploy initial instance count equals 1, instance type equals ML, M5, large serializer equals, deserializer equals. Result. This provisions an EC2 instance, loads your model artifacts from S3, and starts a web server like TensorFlow serving or a Flask app to accept REST API inference requests. 7. Can use SageMaker AI notebooks to evaluate data. You use Python libraries within the notebook kernel, pandas, usedf, info, to check data types nulls, df, describe, for statistical summary, mean, std, min, max. Matplotlib/Seaborn use visualizations to understand relationships, histograms to see data distribution, correlation matrix heat map to find redundant features, box plots to identify outliers. SageMaker Python SDK, to detect data drift or bias using SageMaker 5. Clarify, though typically part of the pipeline config, can be analyzed in notebooks. 8. Can import data from S3 to SageMaker AI. Directly in Notebook Pandas. Import pandas as pd-bucket equals, my bucket data key equals data. CSV data location equals S3 ///, format bucket data key df equals pd read CSV data location using Boto3. Python import Boto3's 3 equals Boto3, client, S3 download file my bucket. Data, CSV, local data, CSV for training jobs. You don't verify import into the notebook, but define training input pointers to S3 paths, so the training cluster can download the data automatically. 03, SageMaker deploying a Model 1. Can explain the different steps in an ML pipeline. Train, tune test, deploy, consumption, monitor, and retrain train. The process where the algorithm learns patterns from the training dataset, SageMaker training jobs. Tune, optimizing hyperparameters like learning rate, tree depth, to find the best performing model, SageMaker hyperparameter tuning jobs. Test, evaluating the final model on a holdout test set to ensure it generalizes well to unseen. Deploy, making the model available for inference, either via a persistent endpoint or batch processing. Consumption, the phase where downstream applications, web apps, mobile devices send requests to the deployed model and receive predictions. Monitor, continuously tracking the deployed model's operational metrics, latency, and model quality, data drift, concept drift, using SageMaker Model Monitor. Retrain, triggering a new training cycle with fresh data when the model's performance drops below a threshold 2. Can explain the difference between a notebook instance and an endpoint container notebook instance. A development environment, EC2 instance running Jupyter, used by data scientists to write code. explore data, and 6. Orchestrate training jobs. It is interactive and stateful but not designed to serve high-scale production traffic. Endpoint container, a separate, optimized compute resource, EC2 instances, that hosts the saved model artifacts inside a Docker container. It exposes a REST API for inference. It is designed for production serving, high availability, and auto-scaling 3. Can distinguish the multiple ways to deploy a model and determine what type of deployment would fit a specific use case best. Real-time inference. Use case, online fraud detection, product recommendations during browsing. Need, low latency, milliseconds, immediate response. Serverless inference. Use case, chatbot used intermittently, low traffic startups. Need, pay-per-use, handles spiky traffic, can tolerate cold starts. Asynchronous inference. Use case, image video processing, NLP on large documents. Need, large payloads up to 1 GB, long processing times up to 1 hour. Returns a job ID to poll. Batch transform. Use case, nightly credit scoring for all bank customers, sentiment analysis on weekly logs. Need, high throughput, cost-effective for large datasets, no need for a persistent endpoint 4. Can explain the difference between endpoint deployment and batch transform deployment. Endpoint deployment. Persistent, resources are always running or sleeping in serverless. Synchronous, client waits for the response. Single micro batch, processes one or a few records at a time. Cost, pay for provision capacity, upped. Batch transform. Transient, cluster spins up, processes data and shuts down. Asynchronous, reads input from S3, writes output to S3. Bulk, processes GBs or TBs of data. Cost, pay only for the duration of the job. 5. Can train and deploy models using SageMaker algorithms on a SageMaker endpoint using different deployment strategies. Training, use the built-in image URIs. Python container equals SageMaker, image URIs. Retrieve, XGBoost, region, latest, 7. Estimator equals SageMaker, estimator container. Instance count equals 1. Estimator fit, deployment strategies. Blue-green, create new fleet. Green, shift traffic 100% when healthy, ensures zero downtime. Canary, shift a small percent, e.g. 10% of traffic to new version, monitor errors, then roll out to rest. A/B testing, keep both versions running, split traffic, e.g. 50/50, compare business metrics to decide winner. 6. Can train and deploy their own custom model on SageMaker script mode, bring your own script. Use a managed SageMaker container, e.g. PyTorch. Write a train, high script that accepts arguments, hyperparameters, and saves the model to OS, Environ SM model dir. Define a requirements, TXT for dependencies. Deploy, SageMaker repackages your script and runs it in the managed container. Docker mode, bring your own container. Build a completely custom Docker image conforming to SageMaker standards, invoking train and serve. Push to Amazon ECR. Point the estimator to this ECR image URI 7. Can create a secure REST API for accessing the endpoint with an API key that clients can use. 1. Architecture. User API Gateway Lambda SageMaker Endpoint 2. Steps. Lambda. Create a Lambda function with IA and permission. SageMaker. Invoke endpoint. Code. Boto 3 client. SageMaker runtime. Invoke endpoint API gateway. Create a REST API. Create a resource/method, post integrated with the Lambda. Security. Create a usage plan, an API key, and API gateway console. Associate the API key with the usage plan and the API stage. In the method request settings, set API key required to true. Client must send the header X API key, your key in the request 8. 4. SageMaker implementing an inference pipeline. 1. Can set up a secure access point to a SageMaker real-time endpoint. VPC interface endpoint private link. By default, SageMaker API calls go over the public internet. To secure this, you create an interface VPC endpoint for SageMaker runtime, COM, Amazonos, region, SageMaker, runtime in your VPC. This ensures traffic between your VPC resources, like Lambda or EC2, and the SageMaker endpoint stays within the AWS network and never traverses the public internet. Security groups. You can attach security groups to the VPC endpoint to control exactly which resources can invoke the endpoint to can explain and compare the different ways to expose a model endpoint. API Gateway, ELB, Application Load Balancer, ALB, and when each is appropriate. API Gateway. Usage. Exposed to external internet clients, web apps, mobile. Pros. Managed authentication, Cognito, IAM, throttling, caching, API keys, validation. Best for public-facing APIs, RESTful services, serverless access via Lambda. Application Load Balancer, ALB. Usage. Expose via standard HTTP/HTTPS within a VPC or internet. Pros. High throughput, path-based routing, native integration with EC2 EKS. Best for microservices architectures, legacy apps requiring fixed endpoints, high-traffic internal apps. ELB, Elastic Load Balancer Classic. Usage, older generation. Note, rarely used for new SageMaker deployments. ALB or API Gateway are preferred. Direct invocation, Bodo 3. Usage, internal AWS services, e.g. Lambda step functions. Best for backend-to-backend communication where no public HTTP endpoint is needed. 3. Can implement a Lambda function that, logic flow 1. Receive, parse event body, from API Gateway 9. 2. Preprocess. Convert formats, e.g. JSON to CSV, resize images, or normalize data. 3. Forward. Use Bodo 3 to call invoke endpoint. 4. Log. Save the input-output to S3 or DynamoDB 5. Return. Send a 200 OK JSON response. Example implementation. Import Bodo 3, import JSON, import OS, import IO runtime equals Bodo 3. Client. SageMaker runtime S3 equals Bodo 3. Client S3 endpoint name equals OS. Environ endpoint name bucket name equals OS. Environ bucket name def lambda handler, event, context, #1. Receive request payload equals JSON, loads. Event body input data, payload data, #2. Preprocess example. Ensure it's a CSV equals join map SDR input data, #3. Forward to SageMaker response equals runtime. Invoke endpoint name equals endpoint name. Content type equals text/CSV. Body equals CSV data. Result equals JSON. Loads. Response body read. Decode. #4. Log to S3 log data equals input. Input data prediction. Result S3. Put object bucket equals bucket name key equals f log/context. Oz request ID JSON body equals JSON dumps log data #5. Return to client 10. Return status code 200 body JSON dumps prediction. Result 4. Can explain the flow of a complete inference pipeline. 1. Client request. User application sends an HTTP post request to API gateway with data e.g. an image or text. 2. Authorization. API gateway validates the API key or IAM credentials Cognito. 3. Trigger. API gateway invokes the specific Lambda function. 4. Preprocessing Lambda. The function validates input, transforms it e.g. base 64 decode image and formats it for the model. 5. Inference SageMaker. Lambda calls invoke endpoint on the SageMaker endpoint. 6. Prediction. The model inside the Docker container calculates the result and returns it to Lambda 7. Post-processing logging Lambda. Lambda formats the prediction, e.g. adds confidence score labels, and logs the transaction to S3 or DynamoDB for auditing monitoring. 8. Response. Lambda returns the final JSON response to API gateway, which forwards it back to the client. 05. SageMaker maintaining an inference. Explain the use of Event Bridge and its connection to step functions. Amazon Event Bridge. A serverless event bus service that makes it easy to connect applications with data from a variety of sources. It delivers a stream of real-time data from your applications, SaaS applications, and AWS services to targets. Connection to step functions. Event Bridge is often used as the trigger for step functions workflows. Example 1. Schedule. A rule runs every Monday at 8 a.m. to trigger a model retraining step function. Example 2. Event. When a new dataset file is uploaded to S3, Event Bridge detects this event and triggers a batch transform step function. 2. can implement a queue and explain the value of adding a queue with a service like SQS in our pipeline value of SQS, simple queue service. Decoupling. Separate the ingestion API gateway from the processing Lambda/SageMaker. 11. Buffering throttling protection. If traffic spikes 1000 requests sec, but the endpoint can only handle 100 sec, SQS absorbs burst. The processing Lambda processes messages at a controlled rate, preventing invalid dropped requests. Reliability. Retries failed messages automatically. Implementation flow 1. Client API gateway SQS, store message and return 202 AC septed. 2. Lambda event source mapping. Polls SQS, invokes SageMaker endpoint stores result in DB3. Can implement and explain step functions concept. AWS Step Functions is a low-code, visual workflow service used to orchestrate AWS services, automate business processes, and build serverless applications. It manages state, checkpoints, and restarts to ensure your application executes in order and as expected. Implementation. Refined using Amazon States Language ASL, a JSON-based structure. States task, do work, run a Lambda, start a training job, choice. Branching logic, if accuracy 90%, go to deploy, else stop. Wait, delay for a specific time, parallel, run branches simultaneously. 4. Can explain the different workflows in step functions, standard workflows. Duration, up to 1 year. Execution, exactly once. Use case, long-running processes like model training pipelines, ETL jobs that verify human approval, express workflows. Duration, up to 5 minutes. Execution, at least once. Throughput, high 100,000 plus per second. Use case, high-volume event processing, orchestrating microservice for a real-time inference request. 5. Can explain the concept of monitoring and data drift monitoring in SageMaker. Using SageMaker Model Monitor, to continuously inspect the quality of the models in production. It captures input/output data from endpoints and stores it in S312. Data drift. This occurs when the statistical properties of the input data, live traffic, change over time compared to the data the model was trained in baseline. This usually leads to model decay, degraded accuracy. 6. Can explain the different types of data drift, covariate shift, input drift, the distribution of independent variables, features, changes. Example, model trained on photos of sunny roads, but now receiving photos of snowy roads. Concept drift, model drift, the relationship between the input variables and the target variable changes. Example, housing prices model where the market dynamic changed due to a new law. The same house features now result in a different price. Label drift, the distribution of the target variable changes. Example, a spam filter typically sees 10% spam but suddenly sees 90% spam due to an attack. 7. Can explain methods of detecting data drift and measuring it. Detection method, SageMaker Model Monitor. 1. Baseline. Create a baseline dataset, statistics like mean, quantile distribution from the training data using a baseline job. 2. Schedule. Set up a monitoring schedule, e.g., hourly. 3. Analysis. The monitor effectively analyzes captures from current traffic and compares standard deviation statistics against the baseline constraints. Measurement metrics. Kolmogorov-Smirnov, K's, test, used for comparing numerical distributions. Chi-squared test, used for categorical distributions. Kullback-Leibler, KL divergence, measures how one probability distribution diverges from a second expected probability distribution. High divergence equals high drift. 06 Computer Vision 1. Describe use cases for computer vision autonomous driving, detecting lanes, pedestrians, and other vehicles. Medical imaging, analyzing X-rays, MRIs to detect tumors or anomalies. Surveillance and security, facial recognition for access control, detecting intruders. Manufacturing, quality control, detecting defects in products on an assembly line. 13. Retail, cashierless stores, Amazon Go, monitoring shelf inventory. Content moderation, automatically detecting unsafe content in user-uploaded images, videos. 2. Describe the AWS Managed Machine Learning, ML, services for image and video analysis, Amazon Rekognition. a fully managed service that offers pre-trained CV models for tasks like object detection, facial analysis, text detection, OCR, and content moderation in both images and videos. You don't need ML expertise to use it. Just call the API. Amazon Textract, specifically designed to extract text, handwriting, and data from scanned documents. It goes beyond simple OCR to understand forms and tables. Amazon Lookout for Vision, an industrial AI service used to spot defects in manufactured products using Computer Vision 3, lists the steps required to prepare a custom dataset for Object Detection 1. Data collection. Gather a diverse set of images representing the objects you want to detect 2. Data labeling annotation. Draw bounding boxes around the objects of interest in every image and assign them a class label, e.g., car, pedestrian. 3. Splitting. Divide the dataset into training 80%, validation 10%, and test 10% sets 4. Formatting. Convert the annotations into a format compatible with your algorithm, e.g., SageMaker Object Detection, expects a specific JSON manifest format or record I/O. 5. Storage. Upload the images and annotation files to an Amazon S3 bucket. 4. Describe how Amazon SageMaker Ground Truth can be used to prepare a custom dataset service overview. SageMaker Ground Truth is a fully managed data labeling service that makes it easy to build highly accurate training datasets. Workflow 1. Input. Point it to your raw images in S3. 2. Task type. Select bounding box object detection. 3. Workforce. Choose who will label the data. Public. Amazon Mechanical Turk, inexpensive, on demand. Private. Your own employees. Vendor. Third-party professional labeling companies. 4. UI. Ground Truth provides a built-in labeling interface for the workers. 14. 5. Output. It generates a manifest file in S3 containing the labels ready for SageMaker training. 5. Use Amazon Rekognition to perform facial detection function. Detect faces capabilities. It doesn't just find the face bounding box, it analyzes attributes like age, range, gender, emotions, happy, sad, eyes open, eyeglasses, smile. Implementation Boto 3. Import Boto 3. Import JSON client equals Boto 3 client Rekognition response equals client detect faces image equals S3 object. Bucket. My bucket name. My photo. JPG attributes equals all. Hash request all facial attributes for face detail in response face details print. The detected face is between plus SDR face detail age range low plus and plus SDR face detail age range high. Years old print smile. Plus SDR face detail smile value 07 NLP1. Describe common real-world use cases for natural language processing. Sentiment analysis. Determine if a customer review is positive, negative, or neutral. Text classification. Categorize support tickets into billing, technical, or feature request. Named entity recognition, NER. Extract names, dates, locations, and organizations from contracts. Summarization. Generate a concise summary of a long news article. Machine translation. Translate product descriptions into multiple languages. Chatbots. Automated customer support agents. 15. 2. Describe the AWS fully managed NLP services. AWS offers a suite of AI services that provide NLP capabilities via API requiring no machine learning expertise. Amazon Comprehend. Natural language processing text analysis. Amazon Translate. Neural machine translation. Amazon Transcribe. Automatic speech recognition audio to text. Amazon Polly, text-to-speech, text-to-audio. Amazon Lex, conversational interfaces, chatbots. Amazon Textract, document analysis, OCR plus structure. 3. Explain what kind of NLP task each service solves. Amazon Comprehend, solves entity extraction, sentiment detection, language identification, and topic modeling. Amazon Translate, solves the problem of language barriers by providing fluent. Amazon Transcribe solves the problem of converting speech, meetings, calls into searchable text. Amazon Polly solves the problem of generating lifelike spoken audio from text. Amazon Lex solves the problem of understanding user intent from speech/text to drive a dialogue for. Compare managed NLP services to building a custom NLP model. Managed services, e.g., Comprehend. Pros: no ML expertise required, serverless, pay-as-you-go, fast time to market. Cons: specific domain vocabulary might be missed, though custom entities helps. Limited model architectural control. Custom NLP model, e.g., SageMaker plus Hugging Face. Pros: full control over the algorithm, BERT, GPT, can be fine-tuned for very specific niche domains. Cons: requires high ML expertise, requires collecting and labeling large datasets, burden of managing infrastructure and training pipelines. 5. List the steps to prepare textual data for custom classification in Amazon Comprehend 1. Data collection, gather text samples for each category 2. Formatting, create a CSV file UTF-8 encoded. Format, label text e.g. SBORTS, the team won the game. Rules, no header row. Minimal 10 examples per class, recommended 50 plus. 3. Upload. Upload the CSV to an Amazon S3 bucket 16. 4. Training. Create a custom classification job in the Comprehend console, pointing to the S3 URI 5. Inference. Once trained, create an endpoint or run a batch job to classify new text 6. Use the different NLP services that AWS provide. Comprehend sentiment. Import Boto3 comprehend equals Boto3 client comprehend response equals comprehend. Detect sentiment text equals I love using AWS services. Language code equals N print respond sentiment. Hash positive translate. Translate equals Boto3 client translate. Result equals translate. Translate text text equals hello how are you. Source language code equals N target language code equals FR. Print, result translated text. Hash bonjour, common allez-vous, 8gen AI 1 explain generative AI and how it differs from traditional ML models. Traditional ML, discriminative, focuses on finding patterns in existing data to make predictions or classifications. Goal, predict a label e.g., is this a cat? Will the stock go up? Output, a class, a number, or a probability. Generative AI focuses on creating new content that resembles the training data. Goal, generate novel artifacts, e.g., write a story, draw a picture, write code. Output, new data instances, text, images, audio. 17. 2. Explain the role of foundation models, FMs, and why they matter for modern AI. Role, foundation models are massive models trained on broad data, unlabeled, that can be adapted to a wide range of downstream tasks. Why they matter? Versatility. One model can perform summarization, translation, Q&A, and code generation without needing separate models for each. Efficiency. Developers don't need to train models from scratch, which is prohibitively expensive. They can just prompt or slightly tune an existing FM3. Describe the difference between training, fine-tuning, and inference in the context of Gen AI. Pre-training. The initial phase of creating a foundation model on a massive dataset, e.g., the internet. It learns language, facts, and reasoning. High cost takes months. Fine-tuning. The process of adapting a pre-trained FM to a specific task or domain, e.g., medical diagnosis, using a smaller labeled dataset, moderate cost, takes hours/days. Inference. The process of feeding an input, prompt to the trained/tuned model to get an output response. This is the runtime usage for. Explain what Bedrock is and what the difference with SageMaker Jumpstart is. Amazon Bedrock. Type. Serverless API, fully managed. Experience. You call an API to access models from Amazon, Titan, and third parties, Anthropic, Cohere, AI21. Infrastructure. You don't see or manage servers instances, ease scaling. SageMaker Jumpstart. Type. Model Hub infrastructure control. Experience. You select an open source model, e.g. Llama 2, Falcon, and deploy it to a specific SageMaker endpoint instance. Infrastructure. You have full control over the instance type, configuration, and model weights. 5. Explain what Inferentia and Trainium offer for LLMs. AWS Trainium. Custom silicon, chips, designed by AWS specifically for training deep learning models. It offers higher performance and lower cost compared to comparable GPU-based instances. AWS Inferentia. Custom silicon designed by AWS specifically for high-performance, low-cost inference. It drastically reduces the cost of Run 18. ending LLMs in production compared to GPU's 19.